Hi guys. Today we're going to make a program together that detects the human body with a camera and then recognizes bicep curls and high knee movements. That means when you stand in front of the webcam, the program knows where your head, hands, legs, and torso are. It's super cool, like something out of a sci-fi movie. Okay, now let's go line by line and see what's happening in this program. First, we imported two important libraries, one is CV2 and the other is pose detector from a package called Zone. To put it simply, CV2 is what helps us work with images and videos, like a wizard of images. And pose detector is a special part of that wizardry that can detect the human body in an image, like saying, here's your head, there's your hand, and that's your leg. Next, we created something called CAP. Think of it as telling the computer, hey, turn on my webcam. And with the number 0, it understands to use your laptop's main camera. Now, here the program says, I want something that can find the human body in an image, know where the head is, where the hands are, and where the legs are. So when you call pose detector, you're basically creating a smart entity that can find the body map from the image. Like a vision robot that can say, that small point is the right hand, that one is the left shoulder. Now the program goes into an endless loop, meaning until you tell it stop. It keeps taking new images from the camera and analyzing them. In this line, imagine there's a cameraman in front of you. Every time you talk to it, it takes an instant snapshot of the scene and gives it to you. This line is exactly that request photo from the camera. But besides the photo itself, another answer is returned that says, was the photo successfully taken or not? What is returned and what are they? Success, this is a Boolean value. If true, it means the camera actually captured a frame/photo at that moment and the frame is ready. If false, it means there was a problem, the camera is off, no access, the cable is disconnected, Android/Windows didn't allow it, or no device exists with that ID. Frame is the actual instantaneous image. It's an array, like a matrix, usually of unsigned 8-bit integers, U and 8, and 3 color channels, B, G, R. That means each pixel has 3 numbers representing the intensity of blue, green, and red. Right now it's shaped like 480 rows, 640 columns, 3 channels. If the frame is empty, its value is usually none, so you have to make sure before working. Imagine one day your camera is disconnected or not working properly. The program needs to know whether it got an image or not. So it does a small check. It asks, did I manage to get a photo or not? If the answer is no, it means either the camera isn't connected or something went wrong, and then very politely exits the loop and finishes the program. Along with this, there's another cool feature. Whenever you want to exit the program, you just press a key, the letter Q. Then the program understands you said, okay, that's enough. I'm tired. And neatly closes everything and says goodbye. Next part, we said to flip the image. Do you know why? Because when you stand in front of a webcam, everything appears mirrored. For example, you raise your right hand, but in the image it goes to the left. We said no, we don't want that. Flip it so it looks natural. Okay, now imagine you're standing in front of the camera. The program is filming you, but it still doesn't know exactly where your head, hands, or knees are. This is where pose detection comes in. We talk to it like a smart brain and say, look. Where's the human body in this image? Show the joints. And it does exactly that. Where we use find pose, it means we're telling our AI model, hey, look at this image, find the human body in it, and mark every joint like shoulder, elbow, knee, and wrist. So when this command runs, it's kind of like a painter drawing points on our photo and connecting them with lines to make a skeleton of the body. Can you imagine? A stick figure drawn on your image and its movements match yours. This step just prepares the image for analysis. Now that the body is found, we need to know the exact position of each joint in the image. Here we use find position. This command creates a long list of all the body joints. For example, 0 is usually the head or nose. 11 is left shoulder. 24 is right hip. 26 is knee. And so on down the body. Each of these numbers in that list has an X and Y coordinate, meaning it tells exactly which pixel that point is located in. This information is very important because we can calculate angles or know whether the hand is raised or the knee is bent or not. Besides that list, we also get something called box or bounding box. This box is a rectangle drawn around the whole body, showing the area the person occupies. It's like when you draw a frame around a photo of a person to say only this part matters. This line is kind of like the program's magic window. Imagine your computer camera is on and filming you. Now we want to show that image to see if our program is detecting correctly or not. This line does exactly that. It opens a window named something like body detection, and shows the live image from the camera inside it. Like looking at yourself in a mirror, except it's a digital mirror. The next line is used when we're done with the camera. If we don't have this line, it's like the camera stays on endlessly and consumes power. So with this command, we tell the camera, "Thanks for your help, you can rest now." And the last line is like the final scene of a movie where everything ends and the screen goes black. Meaning when we want the image window we open to close, we tell it, "Goodbye. Go to sleep." If we don't write this, we'd have to manually close that window with the red X, which isn't very professional. Now when we run it, a window opens that detects all the body points. Now we're going to the more exciting part of our project, where we don't just detect the body but also detect bicep curls. That means when you lift and lower your hand, the program understands and says, "Ah, a bicep curl happened," and counts the number of curls. First of all, we have two new variables, x equal to 0 and hand underscore up equal to false. Simply put, x is the number of times you raised your hand, like a counter. Hand underscore up is a small flag that says whether the hand is currently up or not. This way the program knows, is the hand up now? Yes or no? So it doesn't count the same movement twice. Then in the main loop, like before, the image is taken from the camera, flipped, and the body is found. But now something new is added. When the body is found if in list, it means we're sure the body is detected. We take 3 important points from the body: shoulder stored in point 1, elbow stored in point 2, wrist stored in point 3. First of all, what is a list? A list is a very large list that contains all the body points detected by pose detector. Each body point, like head, shoulder, elbow, knee, etc., has a special number called an index. For example, number 12 usually corresponds to the right shoulder. Number 14 corresponds to the right elbow. Number 16 corresponds to the right wrist. Meaning each of these numbers represents a part of the body. Now why did we put 0 and 2? Simply put, each point in the list itself contains several numbers, like 300, 259, 0, which means 300 horizontal coordinate on x-axis, 259 vertical coordinate on y-axis. The third number is the confidence or certainty that the model is sure about that point. For now, we only need the first 2 numbers, the x and y coordinates, because to calculate the angle we just need to know the exact position on the image. So we wrote it this way. To take only the first 2 numbers from this list, x and y, the third we don't need. The 0 means from index 0 up to 2. In fact, we're saying, from the body list, take point number 12, the right shoulder, but only give the first 2 numbers. And we do the same for elbow, 14, and wrist, 16. Result? We have 3 exact points on the right hand that we can use to calculate the elbow angle. Now what do? With a very cool command from the same library, we say, calculate the angle between these 3 points. That means it actually calculates your elbow angle. When your hand is straight, the angle between them is about 180 degrees, fully extended, but when you curl your arm for a bicep curl, this angle becomes smaller, like 20 degrees or even less. So now our program can know whether your hand is up or down, just by the angle number. Now we say if the angle is less than 20 degrees, the hand is up. But we also write another condition in that statement because this program keeps checking repeatedly and might count before the hand is fully down. So if previously the hand wasn't up, we know a new movement just happened, then we add 1 to the counter. And set hand_up to true to know it's still up and not to count again. Otherwise, meaning the hand went down, the else part says, okay, now the hand is down, turn the flag off. So hand_up becomes false again. And is ready to detect the next movement. In the end, we use cv2.imshow to show the image. And if you notice, the program draws a line or angle on the image to show exactly what it is measuring. Meaning when you raise your hand, a red angle appears on your arm, as if you're seeing your curl angle live on the screen. Summary of the story: with AI, the body and joints are detected. The angle between wrist, elbow, and shoulder is calculated. Each time the angle decreases, hand goes up, a number is added to the counter. And you can control your bicep curl workout without a coach and know how many curls you did. And now we're going to add a new exercise called high knees. Meaning our program detects every time you lift your knee and counts it like a smart coach. Well, we still use the same magical library, the pose detector that knew how to detect body parts, but this time instead of the hand, we deal with the leg. Now exactly what happens? As always, we use the camera image and detect the body, but this time instead of taking shoulder, elbow, and wrist, we go for hip, knee, and ankle. These 3 points also have their own specific numbers in the body list. Point 24 usually corresponds to the right hip. Point 26 corresponds to the right knee. And 28 corresponds to the right ankle. So now it's like the program is placing 3 points on your right leg. 1 at the top on the hip, 1 in the middle on the knee, 1 at the bottom on the ankle. With these 3 points it can calculate the leg angle, meaning it can know if your leg is straight or bent. A very important part here is the angle section. The program constantly calculates the angle between hip, knee, and ankle. And just like the bicep curl, imagine standing in front of the webcam doing high knees. The program draws a red line on your leg, shows the angle next to the knee, and every time you lift your knee, a new number appears on the screen. You feel like you have a smart coach counting your movements accurately. And that's our program for today. Did you see how with just a few lines of code we could detect the body and count arm movements? I hope this tutorial was as exciting for you as it was for me. If you enjoyed the video, make sure to give it a like, and if you want to see more cool projects, subscribe and turn on the bell. And don't forget to tell me in the comments what you'd like us to build together next time. Until the next video, code, be creative, and always keep going with a smile.